Okay, so I went ahead and plugged it in, and then you can see it's about not quite the 16,000. I left it at 11.6, but it's pretty close. Okay, next one. All right, let's see. So this one, they gave you the equation, so I'm just going to use that in. It says if there are an initial 2,000 bacteria in a culture and the number of bacteria double each hour, the number of bacteria after T hours can be found by using this formula. So that's T, this, and always know what your variables stand for. So that's the number of bacteria, and T stands for hours. How many bacteria will be present after 1 day? Okay, so we're trying to find out the bacteria. So what number do I plug in for T? 1? No, it's not 1. That was a trick question. Again, no, this is in T hours, and they want to know how much is present after 1 day. So if this is in hours, well, 1 day has to be 24. And this number is going to be big. I don't even know if my calculator would do it. Let me see. Okay, yeah. So I got 3.355 scientific notation. So times 10 to the 10th. So moving it over. Should I write the whole thing down? All right, let me pause this. Okay, so I wrote down this entire number right here. And then it's a 3.3, so I moved it over 10 spaces and then put my commas in. So scientific notation, or this is how many bacteria you would have. A lot, okay? So here we have, there's initially 1,000 bacteria and they double every hour. They give you the equation. Again, T stands for hours. How long will it take the culture to grow to 60,000 bacteria? So we want to know our final result is 60,000. And we're solving for how long. So how long is going to be the T? Okay, so first thing you're going to do is go ahead and simplify this. So divide by 1,000. So 60 is equal to 2 to the T. Now how do you solve that? You take the log of both sides. So what that allows you to do is to bring the exponent down to the front. So now you have log 60 equals T log 2. From here, you're solving it for T, so you're going to divide both sides by log 2. So I'm going to use my calculator for this one. So log 60 divided by log 2. About 5.9, so about 5.9 hours. So in about 6 hours. Right. Okay, next problem. Okay, so our next problem, it says you have this company, how much it's worth is modeled by this equation. T represents the number of years, and what's the projected annual percent of growth? What is projected annual percent of growth, and what should be the company be worth in 2013? Okay, so there's two questions. What is the projected annual percent of growth? The projected annual percent of growth, because this is a 1.08, 1 includes your original amount and the 0.8, so your percent of growth is going to be 8%. Okay, what should the company be worth in 2013? This is the equation given in 1999. So the difference between 1999 and 13 is how many years? Okay, so then we're just going to plug this into our calculator. Equals our projected value. So I went ahead, plugged it into my calculator. And again, if you're using your cell phone, you want to do this in pieces. You're going to do 1.08 to the 14th power and then multiply that to 256. If you have the nice calculator, you can type it all in. And again, it does order of operations. So it does exponents and then multiplication. It's about $751 million or $751.9 million. Next problem. A small business has a total of 320,1999. Each are between, approximate the sales. Okay, so this did not give you an equation, so I have to go back and look at which equation it is. It does not say anything about compound. It is not decreasing, so it is increased. So it's going to be this one. Okay, this is growth and this is your decay. I'm going to write it down, set it up. So I went to go set this problem up, and we know it's growth, got it, and our principal value is 320. Our interest rate was 12%, so 0.12. Time. I had to read this a couple times. So this is the sales in 1999, and then it says each year between 1990 and 1996, they increased by 12%, approximate the sales for 2015. I don't know, those numbers don't all quite make sense, but I know that this is, they want me to know the approximate sales in 2015. I'm going to go ahead and use this equation, but what years should I use? Well, since this was the beginning balance in 1999, I'm going to say it's the difference between 1999 and 2015. So we're going to go with 16 years. Plug that into your calculator and whatever that is. R26. Okay. All right, about 1.9 million. Nice. Next one. A sports car, and this is kind of neat because cars lose values unless some specialty cars. So here we go. A sports car is purchased in 2004, and some cars actually retain their value more than other cars. So when you guys purchase your cars, so that might be something that you look into. Okay, a sports car is purchased in 2004 for 96. It depreciates. Depreciates means that it's going to be losing value. So it's going to be this one. I'm going to write down the equations, set it up. All right, so from 2004 to, so this was our beginning money, the interest rate, depreciation, so it's losing value. 2004 to 2020 is 16 years. Plug that into my calculator, and I get about 64,000 is what the car is worth. All right, so this is the last page and probably the most important page, and the reason for doing logarithms is to solve all types of problems like this. So there's different ways to solve equations, and so this all comes into place. So this one, what you want to do, 9 and 27, you can actually write as a common base. So the common base is going to be 3. 3 squared is 9, and 3 cubed is 27. And then you're going to multiply these exponents out. So this is 3. Distributive property. If you have 3 to this power and 3 to this power, well, then you know that these powers are equal. So you're going to say and then from here, you're just going to do your math and solve. And you could plug it back in and check. 5 to this power is equal to 5 to this power. Well, that's nice because you have the same base. So then you know that 3x is equal to x plus 8. Do your math and solve. The math is easy. It's knowing what to do and the first steps to setting up that is a little bit tricky. This one. Okay, there's no way that I can rewrite 8 as a power of 5. So in this case, I have to take the log of both sides. Well, what does that let you do? It lets you bring your exponent down in front. So x log 5 equals log 8. I'm solving for x, so divide both sides by log 5. And again, this is not 8 divided by 5, the log of that. It is log 8 divided by log 5. So in your calculator, log 8 divided by log 5 is 1.29. If you had done log 8 divided by 5, this is wrong, and so students also do that mistake. Okay, the correct answer is this. And again, if you weren't sure, you could always do it in 2 steps. Log 8 divided by log 5. 1.29. Next one, here we have, so first isolate your variable. All right, so 2 options for this. You can either say, oh, I already know the answer. 2 squared is 4, so just think about it. You can also rewrite it with the same base. 2 to the x is equal to 2 squared. Okay, so x is equal to 2. You could have also done the change of base formula, which is essentially that. So you're going to take the log of both sides. Bring that in front, so you get x log 2. Divide by log 2. X is equal to log 4 divided by log 2. Okay, so you could have done think about it or change of base. Definitely change of base or this one for this, but this one you could have seen it. All right. Okay. Here's a good one. Same thing. Again, you only have a variable x. E is a number, so you're just going to isolate that x, so minus 9 from both sides. Divide by negative 4 on both. Well, you can think about it. E to what power is 1? E to the 0. So x is equal to 1. Or x is equal to 0. If you didn't like that, you could have said, you actually have a change of base. But for E, you don't take the log of both sides, you take the natural log of both sides. And so this gives you x natural log of E equals natural log of 1. X is equal to natural log of 1 divided by natural log of E. And if you plug that into your calculator, let's see, you have to clear this. Okay. So natural log of 1 divided by natural log of E, change of base, so you get 0. Or you could have just thought about it, it would have been faster. This one's nice. It says log of this is equal to log of that. Well, if log of this is equal to log of that, then you know that x plus 3 has to equal 3x plus 1. Do your math and solve. Okay. And x is equal to 1. Same thing, if the natural log of this is equal to the natural log of this, I'm not sure why it's so light, then you know that those two things are equal. So do your math and solve. Oops, did I do this wrong? divided by 5. All right, this one, you're going to change it from logarithmic to exponential. This is a nice problem. So you're going to change it from logarithmic to exponential. 8 to the 2/3 equals x minus 5. Okay, this is still ugly. This, I'm going to change it. I don't know what it means. So it is the 3rd root of 8 squared equals x minus 5. Well, the 3rd root of 8 is 2. 2 squared is 4. And the last thing you're going to do is add 5 to both sides. And your answer is 9. And again, you could plug that 9 in and check to make sure that's correct. All right, this one, I think I'm going to go ahead and divide by 3 on both sides first. Then I'm going to change it from logarithmic to exponential. So 5 squared equals x plus 2. Clean that up. So x is equal to 23. All right, next one that you can't see. All right, you can either divide by 4 or bring it back up. This is an ugly problem. Let's see. Let's go ahead and divide by 4 here. So this is now going to be natural log 2x equals 5/4. I'm going to change it. I'm going to change it from logarithmic to exponential. How do you change that one from logarithmic to exponential? That's natural log. What's your base here? When it's natural log, it's an implied base e. Maybe I'll make this a bonus one because I don't think I did that in your notes. So we're going to change that to e to the 5/4 equals 2x. Well, I don't know what e to the 5/4 is, so I'm going to use my calculator. And I'm going to say e to the 5/4, I'm not sure what it gets like, is about 3.49. So I'm going to say 3.49 equals 2x divided by 2 on both sides. So x is equal to 1.75, we'll say, approximately. Okay, and that is it. All right, so this page right here is probably the most important page from the entire unit because you're learning how to solve equations using logarithms and exponential functions. All right, that's it. Good luck. Ready for your test.